Today we are going to look at three-dimensional geometry. And before we start, we are going to define some terms as far as this topic is concerned. So we are going to do an introduction, and before that we are going to define the topic itself. So before that, because our topic is three-dimension, we are going to see what is three-dimension, and before that we are going to see what is one dimension. When we say one dimension, these are geometric figures that has only length. They are geometric figures or geometrical figures with only length. That's why we are calling them one dimension. So we look at what is two dimension. Two dimension, these are figures with only area, that is length and the width. We have the length and the width. Then, for example, a plane with length and width, you can only get the area. So hence we call these figures two dimension, three dimension, which is our topic. Three dimension, meaning these are figures. Mostly they are the common solids with length, width, and the height. Hence, we say they have the volume. They are the figures with volume. So, one dimension means they are figures with only length. That is just a line. It can only have their lines. When we talk about two dimensions, they are figures with only the length and the width, so we can find the area. Then three dimensions, which is our concern, are figures with only volume. They have the volume. They have all the other, the length, the area, and hence the volume. Now, we want to classify. We have said that all solids, all common solids, they are three-dimensional. They are three-dimensional figures. Hence, we can describe solids, description of solids. Description of solids. We can describe solids using one, vertices, B, edges, and C, the faces, or what we call the planes. We want to show how we can differentiate the vertices, the edges, and the face and the bodies. Hence, for example, if you are given something like this, this is a solid, have the length, the width, the length, the width, and the height. So these lines joining these points, the joining points, these lines are called the edges. Then these joining points where the edges meet are called the vertices. Hence, this plane, the face that is facing you, is a two-dimension because it has length and the width is called the face or the plane. This is another plane or the face. At the lower level, we call them the faces, but when we come to now O level, we call them the planes. They are flat surfaces that are enclosed by edges. Now, we can give another example of a triangle. A triangle has three edges. These are the lines, we are calling the edges. Three vertices. So this area enclosed by the three edges is what we call the plane or the face. That is the introduction of three dimension. In a nutshell, one dimension Geometry means they are figures with only the length. 2 dimension, they are figures with only the area, that's the length times width, which help us to find the area. 3 dimension, they are the figures or solids with only the volume, that is the length, width, and the height. And to describe, and we have said all solids are 3 dimension because they can be, we can calculate the volume of those solids. We describe the solids. How can we describe solids? We can use vertices, we can use edges, and we can use the faces or the plane. And we have given an example that the lines that are joining, like this one, that are some of them are parallel to each other, they are called the edges. And the points where the edges meet are called the vertices. And the area enclosed by the edges are called the planes. Now, from there, if we understood that, we are going to look something else. What are projections? We are going to do, in this topic, we are going to see the relationship between lines and planes. That is our main concern in this topic. If we understood that, we understand that we are going to close the topic. Now, what is the relationship between lines? In our cases, in our figures, in 3 dimensions, these are our edges. And our planes are our faces. So, to see the relationship, we are going to draw a pyramid. We are going to draw a pyramid. This is a pyramid. That's called A, B, C, D. Then at the top is there. Then the center here is O. So, the relationship. We have lines or edges VA. We have VB. We have VC. These are lines. The edges. VB, we have it, and VD. Now, first of all, we want to see what do we say are projections. Projections. We must understand this term, projections. Projections. For example, projection of VA. This means when you introduce a source of light at this point above V, above the solid, where will be the shadow of VA? The shadow of VA, when you find the shadow of VA, it will be the projection of VA. So it is just like asking, what is the shadow of VA if we have a source of light above? For example, the sun, the torch. Where will the shadow of VA be, which is also the projection? So in our case, VA projection, the projection of VA will be, this V will fall to the center. It will be AO. That's our projection. So this is our projection from V. Now, it goes without saying, VB, the projection of VB will be BO. The projection of VC will be CO, and VD will be DO. So, having understood the projections, we can relate. Now, this is a very important part of this topic. If you don't understand the projections, you cannot understand from the other subtopics. So, we have said the projection of VA is the shadow of VA when it falls on the base, having a source of light above the solid. So VA, the projection is AO. VC, CO. VD, DO. And VB to BO. Having understood that, I'm going to explain the relationship between the lines and the planes. So, I want to explain how can we find angles angle between a line and a plane. The angle between a line and a plane. We want to agree that ABCD is a plane. And we can find the angle between that plane and any of the edge. For example, VA and the base. Let me assume like this. So this is V, A, B, C, D. You want to find the angle between VA and the base, A, B, C, D. An angle between a line and the plane. So the first step is to find the projection of the line. The projection of our line is VA. The projection of VA is A to the center. O. A, O. So this is our line, the projection. Then to get our angle between the angle between VA and the base, which is our plane, is the angle between the line and the projection on that plane. This means it is the angle between the line and the projection. The projection is this. The angle between the line and the projection, and remember this projection is on the plane. So this angle, remember the height of the pyramid is perpendicular. Is perpendicular to AC. So now we can find the angle using SOHCAHTOA, O, A, V. So if you want to get beta, this is our angle beta. So this angle gives us the angle between the plane and the line. If you want to test others the same way, it is the angle, the projection of VC is CO. This is the angle between that. So if you are given either of this or this or this, you can use the SOHCAHTOA. To find the angle between those things. So that is all for lesson 1. So until we meet again to lesson number 2. Thank you. I hope you will follow the next lesson.